What's up everybody? Before diving into routing protocols like EIGRP and OSPF, let's explore VRF to know what it is used for and how we can configure it. This segment of the course is significantly important in CCNP, especially for understanding ISP technology. So give me your full attention to deeply understand the concepts about VRF for the beginning, as we will be working with it in the future in the upcoming videos. Now tell me, what is exactly VRF? What is VRF? VRF stands for Virtual Routing and Forwarding. It is a technology that allows multiple instances of a routing table to coexist within the same router simultaneously. In other words, each VRF maintains its own separate routing table, interfaces, and forwarding decisions. VRF is commonly used in large-scale networks, especially in service providers, to segment traffic and create isolated routing domains. How it works? Imagine within a single physical router, there are multiple virtual routers. These virtual routers operate independently, as if they were separate physical devices. So we can have several routers in one physical router. And that might be surprising for you if I say that you can have the same subnet mask and even the same IP address on each interface and sub-interface, and it doesn't give you overlap IP error if you assign the interface or sub-interface to the VRF, which is absolutely astonishing, guys. If you wonder what does it actually look like, I can say it's just like VLAN, that we can have several switches in one switch, right? That's interesting. Now, what are benefits of using VRF? Isolation. VRFs allow network administrators to isolate traffic, ensuring that routes from one VRF do not interfere with another. Scalability. Large networks have benefit from VRFs by efficiently managing routing tables. Security. VRFs enhance security by segregating traffic and preventing unintended communication between different segments. I prepare a very useful and practical laboratory to deeply understand VRF, so follow me until the end of this video. Alright, let's go. Okay, this is our scenario. There are two states beside each other in the United States, in Oregon and California. And for example, there are two different companies, including Microsoft and Cisco. Microsoft Office from Oregon wants to connect to its branch in California, just like Cisco that wants to connect this to its branch in California from Oregon. So we have four sites in this scenario. As you can see, each site has its own router at the edge to connect to outside, right? And also you can see the dedicated IPs that we're going to assign on each router, the interfaces that are connected to their routers in ISP zone. And each company wants the connection and its path private in order not to be seen from nowhere. And we're supposed to give them service as the service provider, because in this scenario, we're working in ISP company. In here, in the middle. I know that's a little bit fantasy. And for example, we have two routers in ISP zone. For example, each router is settled in different states as a bridge. And we connect these two routers through one physical link, and we're going to assign the same IPs in ISP routers. As you can see, the IP is 10.10.10.0 with prefix /30. And as a result, the subnet mask is The last octet of the subnet mask is 252, which means that we only have 4 IPs. We're just able to assign 2 IPs to the nodes because the first host ID 0 belongs to network and the last host ID with number 3 belongs to broadcast. So we only can assign 1 and 2 to the nodes in ISP Oregon and ISP California. Then, as a result, you can see how we assigned the same IP and the same network with no overlap IP error in one physical router through VRF. And I have to say that doesn't matter how we connect these routers in ISP, whether through wireless or optic channel, because this doesn't have to do with our subject at the moment, right? But we're supposed to create sub interfaces on this link. Why? Because we have 2 different connections, right? The connection with orange color is specified for Microsoft connection, and the other connection with yellow color belongs to Cisco company connection. Now, what's the plan? The plan is to create VRF for each connection. In this scenario, we have 2 connections. The connection with orange color does belong to Microsoft, and we're going to create VRF with name VRF-Microsoft in this router at the edge for Microsoft router, and also for Microsoft router in California. And also we're going to create VRF-Microsoft in the routers in ISP zone in the middle, in ISP in here. Also, we have another VRF and another connection for Cisco company, and it is specified with yellow color. As always, we're going to create VRF-Cisco as we wrote down in here already, VRF-Cisco in Cisco router in Oregon, and also we're going to create that VRF with the same name in Cisco router at the edge in California. And as always, we're going to create in ISP routers with this name. So we're going to have 2 different VRF names in ISP zone routers. And then we need to setting the address family, which is IP4, V4, and then the most important part is assigning the connected interface to the VRF. So for example, this interface, which is connected to Oregon Microsoft, which is, for example, interface fast Ethernet 1/0, which belongs to Microsoft router in Oregon, is supposed to assign to VRF-Microsoft. This connection that is specified with orange color it looks like a pipe, and all the traffic is completely separated. So we're going to assign this interface, which is fast Ethernet 1/0 in California, the edge in California for Microsoft, is going to be assigned in VRF-Microsoft as well. And as a result, these routers for Cisco company are going to be assigned in VRF-Cisco, right? And another thing I have to tell you, and after, by the way guys, and after assigning these interfaces to this specific VRF, and there we are allowed to assign IP to the specific interfaces, right? And by the way guys, because we only have one physical router to connect the ISP routers, we're going to create our interfaces, two interfaces. Why two interfaces? Because we only have two connections, Microsoft and Cisco. So we're going to create sub interface with VLAN ID 10 for Microsoft connection, and we're going to create sub interface with VLAN ID 20 for Cisco connection. We're going to create two interfaces for this link, which is, let me see, it is, for example, fast Ethernet 0/0. It's gonna be, for example, 0/0 .10 and .20. Is that right? And guys, I'm gonna do all these things I'm saying in the project practically, so you're gonna understand it completely, so don't worry about that. I start the task from Oregon Microsoft in this router. So to start the task to create our VRF, we have to go to global mode, and then with the keyword VRF, and then with question mark you can see the next command with definition, and then the name of the VRF. Listen guys, you can define any name you want, but if you define a name on this router, you have to define the same name in the rest of the routers for Microsoft connection. You got it? And in this case, because we wrote down in here already, it is VRF-Microsoft. So the name is supposed to be VRF-Microsoft. And then we have to set the address family, which is IPv4, with address family IPv4. And then we're going to privilege mode. Here we're going to show VRF. We're going to make sure that VRF is created with show VRF. You can see all the VRFs that are created in your router. As you can see, VRF-Microsoft is created with protocol IPv4. Listen guys, this option, protocols IPv4, is so important. So if you don't specify this option, it is not going to work. Remember that. And after creating our VRF, it is time to go into the interface. What is the interface? It is fast Ethernet 1/0, right? In Oregon Microsoft. So we're going to interface fast Ethernet 1/0. The first thing we have to do is to power on this interface with no shot. And then we have to assign this interface to the specific VRF with the keyword VRF and then forwarding. And the question mark, you can see we have to input the name of the VRF, which is VRF hyphen, what was that? Microsoft. And then we have to set our IP address, which is 15.15.15, and because this is Microsoft router edge, we're gonna assign 2. With the subnet mask, the last octet is 252, and then with end. And now I want to see the routing table. So we're gonna show IP route as always, right? Oops, we don't have any routing in the global routing table. What is global routing table? As you can see, with show IP route, it shows you the global routing table, which shows you by default. But guys, before showing anything, I have to indicate that we have already assign this interface to VRF-Microsoft. So VRF-Microsoft has its own routing table. It is interesting, right? So to see the specific VRF, we have to show IP route, and then guess what? The keyword VRF and the name of the VRF, which is VRF-Microsoft. Here we go. This is the routing table which belongs to VRF-Microsoft, and you can see the IP. Fast Ethernet 1/0. And another thing is interesting I have to tell you is ping. Because when you ping, for example, we want to ping this IP that we just assigned, 15.15.15.2. It gives you timeout. Why? Because when you ping, only ping, it's gonna see the global routing table. Right, so we have to inform the router that this ping, let me show you, ping, and then after ping you can input, guess what, the VRF, right? After ping, VRF, and after VRF, guess what, the name of the VRF, which is VRF-Microsoft. And then you have to input your IP address here, which is 15.15.2. As you can see, the IP is assigned successfully. Interesting, right? And it is time to create our default route. To create our default route, you know that exactly how to create default route, right? So we go into global mode in here, and we input IP route, for example 0.0.0 anyway for the destination IP. But in this case, we have to inform the router that this IP route, this default route, does belong to your VRF, not global routing table. So we have to inform the router that this default route belongs to VRF-Microsoft, the orange connection, right? The name of the VRF is VRF-Microsoft, and the keyword VRF and the name of the VRF, VRF-Microsoft. Great. And the destination IP, which is, guys, I'm gonna leave it to everywhere for the destination IP, but you never ever input everywhere with prefix 0. You should always use the longest prefix match. For example, let me show you. For example, in this case, we are in Oregon Microsoft router at the edge. So if I wanna use the longest prefix match, I have to input the destination IP, which is 16.16.16. Guess what? 0 with the subnet mask. The last octet must be 252. You got it? But because I don't want to make this video too long, I'm going to use everywhere. But you always use the longest prefix match in your real environment, guys. Remember that. And what is the next hop? It's supposed to be 15.15.15.1. This interface, which is connected to Microsoft router in here. It's supposed to be with host ID 1. And then we want to see this routing table. We want to see this default route. How we can see that? You know that exactly with show IP route and VRF and the name of the VRF, which is VRF-Microsoft. And you see that is everywhere via 15.15.15.1. we have done with this router right now, and it is time to go to Microsoft router in California. First of all, guess what? We're going to create our VRF in global, right? We're going to say VRF definition, and the name of the VRF is VRF hyphen Microsoft. Guys, I repeat that again because it is very important. At the first router, we created VRF with name VRF hyphen Microsoft. We need to specify the name just the same in the rest of the routers. So we're going to specify this just like the same we did in Microsoft router in Oregon, right? So VRF hyphen Microsoft, as we wrote down in here before, in here, which is specified by orange color, VRF hyphen Microsoft. And then we have to set the address family. What was that? IPv4. Great. And then guess what? Let me check it out that it is created or not, which show VRF. You can see that VRF-Microsoft is created. Guys, listen. Protocols, which is the address family, is important. If you don't specify this protocol, which is IPv4 in this case, your connection is not going to work. Remember that. We're going to global mode, and then it's time to assign your interface to the specific VRF. So we're going to interface. What is the interface which is connected to ISP California? It is fast Ethernet 1/0. So we're going to interface fast Ethernet 1/0. First of all, we're going to power on our interface with no shot, and then we're going to assign this interface to VRF with VRF the forwarding, and then the name of the VRF, which is VRF-Microsoft. After that, you're free to set your IP address or whatever you want to do, any change you want to do, right? For example, I'm gonna IP address. What is the IP address? Is 16.16.16.2. And then with the subnet mask, the last octet is 252. And then I'm gonna make sure that this routing table is created. Let me create our default route first and then show the routing table, which belongs to VRF-Microsoft in California router. All right, going to global mode for creating our default route, IP route, and then you tell me. Right, VRF, and the name of the VRF, right? VRF-Microsoft, and everywhere. But you don't input your destination IP everywhere. You always use the longest prefix match, and the next hop is supposed to be what? It's supposed to be 16.16.16.1. which belongs to ISP California in ISP zone, right? So the next hop is, let me see, again, IP route VRF hyphen Microsoft, and everywhere, and the next hop is 16.16. As you can see in here, 16.16.16.1, and we're going to show the routing table, which show IP route. As I told you once, which show IP route, you can see the global routing table, which shows you by default. But in this case, we created another connection by VRF named VRF-Microsoft. So because of that, we're going to show IP route for changing the global routing table, we're going to input VRF and the name of the VRF, which is Microsoft. Are we in Microsoft? Of course, in Microsoft. And VRF hyphen Microsoft. And then here we are, the static route everywhere via 16.16.16.1. And you tell me how we ping VRF hyphen Microsoft and then the IP. Here we are, it is set successfully, and it is time to go to Cisco router in Oregon. Do the same in here. We have to create our VRF name VRF-Cisco for the pipe or connection which belongs to Cisco company, which is specified with color yellow. So we go into global mode and then with VRF definition, and the name of the VRF, as the map says, VRF-Cisco. And after that, you don't forget about that, setting the address family, which is IPv4. And after that, exit, and guess what? We're going into the interface. What is the interface? It is fast Ethernet 1/0 as well in Cisco router in Oregon, guys. So we're going to interface fast Ethernet 1/0. First of all, as always, no shot. And then we're going to assign this interface to VRF with VRF forwarding. And then the name of the VRF. Imagine you forgot about the name of the VRF at the moment. So you quickly input do show VRF. And you can see clearly the name of the VRF in here. VRF-Cisco. So again, you say VRF forwarding, and name of the VRF is VRF-Cisco. And then we're going to set IP address, which is 202022. With subnet mask, the last octet is 252. And let me no shot. Okay. And then we're going to exit. We're going to create our default route with IP route. And guess what? VRF and the name of the VRF, which is VRF-Cisco. And the destination is everywhere, because we are in laboratory. As I told you several times, you never ever use everywhere for your private path when you want to see a single IP in another site. Everywhere with the next hop 2021, right? And then for checking the connection, for checking if IP is assigned successfully, ping VRF-Cisco, and then the IP address too. Okay, it is set, and it's time to configure all these things in Cisco router in California. So as always, you know exactly how to create VRF, right? As the map says, VRF-Cisco, VRF definition. And then setting the address family IPv4. And then guess what? Exit, and going to the interface, which is fast Ethernet 1/0 as well. So we're going to interface fast Ethernet 1/0. And then we're going to power on our interface with no shot, and then assigning this interface to the specific VRF with VRF forwarding. And the name of the VRF, VRF hyphen Cisco. And now we are allowed to assign our IP, which is IP address 21.21.21.2 with the subnet mask. And then we're going to exit and creating our default route with IP route VRF and the name of the VRF hyphen Cisco 21.21.21 with the gateway is 1. Oops, I forgot destination IP and destination. Perfect. Which show now I want to show the routing table which belongs to VRF hyphen Cisco, which show IP route. This shows me global routing table, which I don't want to see that, but with VRF, with name of the VRF hyphen Cisco, we can see the related routing table. Here we are. Okay, great. It is time to configure our ISP, our routers in ISP zone, right? I start from ISP in Oregon. So let's go into it. First of all, let's create our VRFs. As I told you before, we're going to create both VRFs, VRF-Microsoft and VRF-Cisco in both routers in ISP zone because these routers are playing a role as a bridge. So we're going to ISP Oregon for creating router. As always, you know exactly how to create your VRF. We're going to VRF definition and the name of the VRF. You have to specify just the same as you specified in the rest of the routers. You remember that, right? So definition, what is the first VRF is VRF hyphen Microsoft. Are we in Microsoft? Of course in Microsoft. Microsoft, and then the address family is very, very important, guys. IPv4. And then exit. It is time to create the other VRF with VRF definition. Name of the VRF is VRF hyphen Cisco, and the address family IPv4. Exit, and which show IP. We do show VRF. You can see the VRFs that were just created. VRF hyphen Cisco and VRF hyphen Microsoft. Great. All right, now it's time to create our sub interfaces. As the map says, we have to create two sub interfaces with different VLAN IDs. Sub interface with VLAN ID 10 is gonna belong to VRF-Microsoft, and sub interface with VLAN ID 20 is gonna belong to VRF-Cisco. So now I'm gonna go into, let me find out what the interface is connected to another ISP router first. It is fast Ethernet 0/0. So we're going to interface fast Ethernet 0/0.10. And then after getting to sub interface For being able to set IP address, we need to first make this subinterface encapsulation.1q with the keyword encapsulation.1q with VLAN ID, right? Yes, and the VLAN ID is 10, and then now we are able to assign IP to this sub interface. Before setting IP address for the sub interface, as always, we need to assign the sub interface to the related VRF. First, no shot, and then I'm gonna assign the sub interface with VLAN ID 10 to, guess what, VRF-Microsoft with, as always, VRF forwarding and VRF-Microsoft. You have to be very careful about this name, VRF-Microsoft, and then after assigning the sub interface into VRF, we're going to assign IP address, which is, I'm going to assign 10.10.10.1 to ISP Oregon for sub interface with VLAN ID 10 and 20 for ISP Oregon, and I'm going to assign with host ID 2 for both for both sub interface 10 and 20 for ISP in California. Now I'm going to add IP address 10.10.10.1 with subnet mask /30 fast ethernet 0/0.20. First of all, we're going to make this sub interface encapsulation.1q with the VLAN ID 20. Guys, if you don't make your sub interface encapsulation.1q, you're not able to set your IP address or any change you want on your sub interface anyway. So it is necessary to make your sub interface encapsulation.1q first. No shot, and then IP address, which is 10.10.10.1 with subnet mask, the same subnet mask. Oh, oops, sorry guys, I have to assign this sub interface into VRF-Cisco first. First of all, we have to VRF forwarding VRF-Cisco, and then assigning my IP VRF. You can see the interfaces of that fast ethernet 0.20 belongs to VRF-Cisco, and fast ethernet 0.10 belongs to VRF-Microsoft. And another thing I have to set is assigning IP to the interface which is connected to Microsoft router in Oregon to make the connection between ISP Oregon and Microsoft router in Oregon. Going to global, and then what is the interface? 3/0, right? Interface fast ethernet 3/0. No shot, first of all, and then we need to assign this interface into what VRF? Of course, Microsoft VRF. And VRF forwarding VRF-Microsoft. Why Microsoft? Because the interface is connected to the Microsoft company. That's why we are assigning this interface into Microsoft VRF. VRF-Microsoft. Okay, great. It is now assigned. After assigning interface into VRF, IP address, which is 15.15.15.1 with /30. And then it is time to ping the connection. Ping what is the VRF name to test the connection to Microsoft router. What is the name? Right, VRF-Microsoft, and IP 15.15.15.2, right? As you can see, the connection is okay. Let me, first of all, before I forget it, let me go into fast Ethernet 0/0, which is connected to another ISP router. No shot, to make sure that this is gonna work. Okay. And in the next step, I need to configure ISP router in California. So we're going to ISP router in California. We do just the same, guys, but I'm gonna firstly configure this interface, which is connected to Microsoft router in California, which is fast Ethernet 3/0. We're going to interface fast Ethernet 3/0 with no shot, and then we have to assign this interface into VRF, but we cannot do that. Why? Because we haven't created our VRF yet. And so we're going back, and we're going to create our VRFs with VRF definition, and the name of the VRF is VRF-Microsoft first. Microsoft address family, which is IPv4. Exit, and we're going to create the last VRF for Cisco connection. VRF definition, and the name of the VRF-Cisco, and address family. IPv4, and then let's go back to interface fast Ethernet 3/0, which was connected to Microsoft router in California, which was the edge router in fast Ethernet 3/0. We have to assign this interface to VRF with VRF forwarding. What is the VRF? Microsoft? Of course, Microsoft. And VRF-Microsoft. Great. And now we are allowed to set our IP address. IP address 16.16.16.1 with slash. The last octet is 252. Great. And now it is time to test the connection with ping. And now guess what? VRF. What is the connection we are testing with? Of course, Microsoft, and the IP. As you can see, the connection between our ISP California router and our Microsoft router at the edge in California is okay. And it is time to configure our sub interfaces. To do the task, we're going to global again. We're going into fast Ethernet. If you remember that, fast Ethernet 0/0, and then no shot. We're going to interface fast Ethernet /0.10. And now we are in sub interface. The first thing we have to do in sub interface is making it encapsulation.1q. So encapsulation.1q, and the VLAN ID, which is 10, and then we're going to assign this sub interface into our VRF, which is VRF forwarding VRF. What is the connection? Right, Microsoft, and then we are allowed to set our IP address, which is, let me show you. The IP address, as I told you, we are going to assign our IP address, which is connected to IP or ISP Oregon. We're going to assign 10.10.10 to and then exit. Let's go to another sub interface, fast ethernet 0/0.20 encapsulation.1q with VLAN ID which is 20, and then assign an interface with VRF. Let me see that we have created VRF-Cisco or not. Let me make sure. Show VRF. Yes, of course, we have created VRF-Cisco. So we're going to VRF, and the name of the VRF, which is, we are in sub interface with ID 20, which is supposed to be assigned in VRF-Cisco, right? VRF-forwarding. I forgot the forwarding. VRF-Cisco. Dot. Guess what? 2, right? It is set successfully, and it is time to check the connection. It is time to check the connection between sub interfaces, between the ISP routers. Right now, I'm going to check the connection sub interface with VLAN ID 20, VRF-Cisco. So I'm going to ping and VRF, the name of the VRF, which is, because I'm going to test VRF connection, gonna input VRF-Cisco, and the IP is 10.10.10.10. and what was the host ID in ISP Oregon? Remember that? It was 1. It is nicely working. And another thing I have to check is the connection from ISP Oregon. So I'm gonna ping. At this time, I'm gonna check the connection VRF-Microsoft with color orange. So VRF, and the name of the VRF-Microsoft. Hello Bill Gates. And what is the IP? 10.10.10 and 2, right? And the connection is okay. Let me try out from Microsoft router in California with ping VRF. We are in Microsoft router in California. So what is the name of the VRF? Right, VRF-Microsoft. And I'm gonna check the IP which is assigned on sub interface 10.10.10, and what was that, 2? Right, it is working, guys. And we're supposed to see ISP Oregon in this leg. So I'm gonna ping 10.10.10 1. It gives me timeout, guys. Why? It is simple, because we haven't created any default route in our ISP routers. So I'm gonna firstly go to ISP Oregon and go into global and IP route. And then guess what? We are going to create a default route for connection name VRF-Microsoft. So we're going to input VRF, and the name of the VRF is Microsoft. What is the next hub? What is the gateway? So we're going to destination everywhere is going to gateway 10.10.10.2. which is ISP California leg sub interface, right? It's 10.10.10.2. It is set. Another thing we have to set is default route for the connection for Cisco company, right? So I'm gonna input IP route VRF, and the name of the VRF Cisco everywhere. and the gateway is 10.10.10. You tell me, what is the gateway? Right, to interesting. That is a technology, guys. It is absolutely technology. And then we are in ISP California. We go into global mode, IP route everywhere. Oops, sorry. Let me check this out. Okay, we are in ISP California. IP route and VRF for Microsoft connection. VRF hyphen Microsoft. Everywhere. What is the gateway? 10.10.10.1. Great. And default route for VRF hyphen Cisco connection route VRF, which is VRF hyphen Cisco everywhere. And what is the gateway? You tell me. 10.10.10. What is the host ID? 1. Great. Let's try out. Let's go to California, Microsoft router, the edge router in California. So now again, I'm gonna ping VRF-Microsoft 10.10.10.1, which is ISP Oregon leg in here. As you can see, the connection now is nicely working. And another thing I have to check is Oregon, Microsoft router, edge router. So I'm gonna, 15 dot, what is that? 2, right? As you can see, the connection is okay. And we're supposed to see California Cisco router, the edge router from Oregon. We are supposed to see that with ping VRF, name of the VRF hyphen Cisco, and then what is the IP? What is the IP? 21, right? We want to see this, we want to test this link. 21, 21, 21, and 2. Why we cannot see that? 21, Cisco. Let me check another connection, 10.10.10, 2. Oregon, Cisco. Let me see if we already assigned the configuration in this router in Oregon. Interface fast Ethernet 1/0. Let me see if we have created our VRF in this router, which do show VRF. Yes, we have created. Let me check out another thing with running. Let me see to make sure. Okay, we have created we have assigned this IP in this interface. It's supposed the problem is from ISP Oregon interface. So we're going to ISP Oregon. What is the interface is connected to ISP Oregon? It is fast Ethernet 3/1, which is connected to Cisco router in Oregon, right? So we do show run. Let's go to 3/1. Okay, see, we haven't configured this interface, so that was a problem. We're going to interface fast Ethernet 3/1, no shot, and then guess what? VRF forwarding VRF. What is the VRF? Cisco, right? And then no shot again. IP address. What is the IP address? Which is 20.21.21. Great. Let me try out ping VRF hyphen Cisco 20.20.22. It is correct. And let me check out this router. If we assign IP to this interface, it is fast Ethernet 3/1 as well, with show running. As you can see, we haven't configured this fast interface as well. So we are in ISP California here. Going to that interface and fast Ethernet 3/1, and then again no shot, and then VRF forwarding VRF hyphen what is that? The connection Cisco, right? Cisco, and then IP address. What is the IP address? 21.21.21.21.1. Easy. And we're supposed to see the other side in California from Oregon. Now we are in Cisco router in Oregon. And now with ping VRF hyphen Cisco, and then guess what? 21.21.21.2. This lake, exactly this lake in California. Now you can see the connection is okay. And another thing I have to show you is show IP route VRF hyphen Microsoft. Are we in Microsoft? Of course not. We are in Cisco router. But I want to show you that with VRF-Microsoft, it doesn't show you anything because VRF-Microsoft doesn't exist in the edge router in Cisco, right? But if I ping VRF-Cisco, it shows you routing table in VRF-Cisco. So as you can see, all the routing, all the static route and default routes are created. Great. Listen guys, we made the connection between office and branch in different cities by VRF. And now if you want to communicate with other LANs, you have to establish your tunnel between the sites, right? And now I have to say goodbye, but I'm going to teach you different protocols like in Cisco, like DMVPN, GRE, and also IPsec, which is really fun. Thank you for watching. I hope you enjoyed that. See you soon.